Hello to all participants around the world, and thank you for joining the third edition of our free online webinar, Hobby Topics. We would like to welcome you to today's presentation about the hard resin fraction of hops. We are broadcasting today from our new Hobbywood studios in Mainburg, Germany. However, as we are still faced with a lot of recommendations to minimize the spread of the COVID-19 virus, my colleague Dr. Martin Biendl will take over the opening ceremony of our new studio while I stay in safe distance. My name is Sandro and I'm working for the technical support at the Hopsteiner, Germany. I'm guessing you've all become familiar with webinars over the past few months, so I'd just like to say a very brief word about our setup. The webinar is scheduled for a total of 1 hour, starting with a 40-minute presentation and followed by a Q&A session. During the webinar, both your microphone and the camera remain switched off, but you can ask your questions and comments at any time through the menu on the right side of your screen. The questions are directed to me and I will pick them up at the end of the presentation. Here with us today is Dr. Martin Biendl, our head of R&D and analytics in the German branch of the Hopsteiner Group. Martin received his PhD in organic chemistry from the University in Regensburg in 1990. His research experience covers the needs of hops for the brewing industry and beyond. He is the representative of the International Hop Industry Corporation in the EBC Analysis Committee and, since 2001, chairman of the Hops Subcommittee. As the EBC representative, he is also the co-chairman of the International Hop Standards Committee. In 2007, he was elected to the board of the German Hop Trade Association. In addition to numerous publications in the international brewing journals, he is also the co-author of 2 books covering the full range of hops. Martin, it's your turn now and have fun on the Hobbywood stage.
Hello everybody around the world. In the today Hopsteiner webinar, I would like to give you some information on the state of knowledge regarding the hard resins of hops. After some definition, I will talk about stored hard resins as compared to native hard resins, and then I will cover some brewing trials and give you a summary in the end. So the definition of hard resins is as follows. There is the so-called Wöllmer fractionation of hops, and the total resins of hops are defined to be soluble in cold methanol, whereas the soft resins are then also soluble in hexane. The hard resins are not soluble in hexane. Usually dried hop cones have about 90% of the total resins are soft resins and only 10% are hard resins. And during storage, oxidative storage with air, there are some changes of these fractions, whereas the soft resins decrease, the hard resins increase. With regard to the specific components, we know since decades that alpha and beta acids are the main components of the soft resins. And for the hard resins, we know since about 20 years that xanthomol is the main component. But until 2014, most of the other hard resin compounds were unknown. And this changed then from this year on. And at first, I talk about the knowledge regarding the stored hard resins. And here in 2014, there was a publication published in Journal of Agriculture and Food Chemistry by a Japanese group, and they analyzed the hard resin components in hops formed during storage. And here are some messages we got from this publication. So xanthomol is well known, and other compounds of hard resin have not until now been identified. So this is exactly what I stated in my slide before. Only xanthomol was known so far. But in this study, the authors analyzed the soft and hard resins derived from stored hops, and they could clarify the existence of these oxidation compounds for the first time. In this study, the hop pellets were stored at 60 degrees for 48 hours. And then the analysis of the degradation products was done. And the main components this group could analyze were humulinones and holopones, but both, so these are degradation products of alpha acids and beta acids, they are part of the soft resin fraction. Whereas 4-hydroxy-allohumulinones and tricyclo-oxy-isohumulones A and B could be identified as degradation products present in the resin, in the hard resin fraction. But they all come from the alpha and the beta acids. And in this paper, there is also a nice picture that show you the distribution of compounds. So soft resins, now we know they have alpha and beta acids, and the degradation compounds, humulinones and holopones, whereas the other compounds, this allohumulinones, are part of the hard resin fraction. And of course, if you add then such hops to the brewing kettle during wort boiling, you get some transformation products, and so there are some more compounds coming from the hard resin fraction. As I told you before, the first paper was on storage of hops under forced conditions, but one year later, the same authors reported that a similar constituent profile resulted from pellet storage at 4 degrees for 3 years in contact with air in the dark. So also during regular storage in the cold stage, if oxygen is present, you get these transformation products. There are some papers of this group, but the taste was not really defined. So for the first, we know there are some aged hard resin components, but the taste is still a little bit unclear to me. Now we come to the so-called native hard resins. So these are the hard resins that are present in fresh hops, harvested hops after drying. And in 2015, there was a study from the chair of brewing and beverage technology. And in this paper, brewing trials with hop pellets were done in comparison to isolated soft and hard resin extracts. And they were investigated mainly with regard to beer quality. And these trials were done in lab scale, 10-liter scale. And here is one table from this paper. You see the analytical and sensory results on the final beers. So that there was one unhopped beer as a comparison, and then one beer was produced with variety Taurus. Pellet type 90 dosage was 520 milligram per liter, and the isolated soft resin extract from this variety and the isolated hard resin extract of this variety was dosed with 150 milligram per liter. The bitter units in the unhopped beers are rather low, of course, and the pellet type 90 and the isolated soft resin extract resulted in more or less the same bitter units. The bitter units of the isolated hard resin extract was lower. And then the bitterness description. Unhopped beer is not bitter at all, and the pellet type 90 beer showed a smooth and mild bitterness. Whereas the bitterness resulting from the isolated soft resin extract was described as harsh and irritating. But the bitterness coming from the hard resin extract was described as harmonic and mild. So this is a very interesting and maybe surprising result. And this could be confirmed also with the aroma variety Pearly, the same fractions, or also iso-alpha or isolated soft resin and hard resin extract was dosed, comparable dosing rates and similar results. So the conclusion from this study are that for both hop varieties, the panel members agreed that the hard resin enriched extract imparted a desirable mild bitterness and a well-rounded taste and character. And in the same year, another paper appeared, and the author is Michael Driesel. He is also from the Technical University of Munich, but he came from the chair of food chemistry and molecular and sensory science. And here is the experimental setup of the studies presented by Dresel in this paper. He did a sensory evaluation of the total hard resin fraction. He isolated and identified all the aroma active components. He characterized their individual sensory activities. He determined their human threshold concentrations, and then he performed recombination experiments to verify the taste contributions. And then he quantified all these taste active components in different hop products and different beers. And here is one table showing the results of taste active hard resin components. This is the group of prenylflavonoids. You see here some compounds like xanthomol, isoxanthomol. You see the bitter taste threshold concentration, and you see a concentration in a beer sample. And you see most of the concentrations are 0.1 milligram per liter or lower. And in addition to these components given in this table, 17 more taste active prenylflavonoids were identified. But as you can see, only one component, isoxanthomol, is present in a concentration that is lower than the bitter taste threshold, but at least it's more in the range of it. Whereas for all the other compounds, the concentration in beer is much lower as compared to the bitter taste threshold. Nevertheless, because these compounds are very similar, they can be expected to interact with the same bitter receptor. So you have an additive effect of all these compounds. This is more than 20 compounds. Concentrations of 0.1 milligram per liter would result in about 2 milligram per liter taste activity. So altogether, they could have an influence on beer taste. And there are even more compounds. Xanthomol is, as I told you before, is the main component. And some derivatives of xanthomols, where this prenyl group made a cyclization, are called xanthomol B, C, D, and E, and so on. Xanthomol is not called xanthomol A, but it's the xanthomol. The compound was discovered about 100 years ago. The correct structure was determined in 1961. And since 1999, this compound became famous because of a wide spectrum of positive activities. For example, anti-cancer, anti-diabetic, anti-inflammatory, antiviral, and so on activities were published for these compounds with this, within the last 20 years, and the research is still going on. As you saw in the table before, not only the native hard resin components are relevant for the beer taste, but also their isomerized products. If isomerization happens during wort boiling, for example, xanthomol is converted to isoxanthomol, and therefore isoxanthomol derived from xanthomol of hard resin is the main compound in beer. And another example is dihydroxanthomol C, which is converted to dihydroisoxanthomol C. So far to the prenylflavonoids, but there are some more hard resin single components as determined by Dresel, cumaric acid and the ester, and a very interesting group, the glycosidically bound polyphenols, quercetin, camphorol glucoside, the camphorol malonyl glucoside, and the co-multividol and ad-multividol glucoside. And 5 more taste-active similar polyphenols were identified. They all show again concentration lower than 0.1 milligram per liter in beer. The highest concentration were determined for quercetin glucoside and camphorol glucoside, but still lower as compared to the bitter taste threshold concentration. For co-multividol glucoside, the concentration in this beer was 1.4 milligram per liter, and this is already close to the bitter taste threshold. This multividol glucoside are known to interact with another bitter receptor as compared to isoalpha acids or prenylflavonoids, but as far as I know, the bitter receptor has not completely identified yet. But again, there is an additive effect of all these components. Just to show the structures and a little bit background information on the compounds, the multivital glucosides are almost unique to hops. They were discovered by Bohr in 2005. And these acylfluoroglucinil derivatives are intermediates in the hop biosynthesis of alpha and beta acids, and they show anti-inflammatory activities. And because they are these intermediates in the biosynthesis, you have the same side groups, and you have the co and the at homologues, and the N homologue was not discovered so far, or was not discovered by Dresel in his studies. The glycosidic bound flavonols, here you see the example of camphorol glucoside, quercetin glucoside. There is also a quercetin rutinoside. So you have different sugar moieties in these structures. They are very widespread in the plant world, and quercetin is well known as one of the strongest natural antioxidants. So all these compounds, also the minor compounds, are present in beer. And Dresel performed what he calls a taste re-engineering experiment. And he had a Pilsner reference beer, and he analyzed all the single components of this beer, bitter components, the iso-alpha acids, as well as the hard resin key bitter compounds, as I have shown you before in the tables. So he could determine the concentration of each individual compound. And from the same brew, he had a zero beer that was not hopped. And of course, the bitterness intensity of the zero beer is very low as compared to the reference beer. And then he spiked the zero beer with the iso-alpha acids concentration present in the Pilsner beer. And the sensory evaluation showed a bitterness intensity of about 2.2. And only if the iso-alpha acids plus all the isolated hard resin key bitter components were present and added to the beer, the bitter intensity of the reference beer was achieved. So this is a clear demonstration of the additional bitterness coming from the hard resin components. And also very interesting, this zero beer with the iso-alpha acids and with all the hard resin key bitter compounds was described as beer-like, long-lasting, and well-rounded without any specific off-taste. So hard resins contribute both to the intensity and to the quality of beer bitterness. So the state of knowledge since this paper is as follows, and as given in the abstract of Dresel. So for the first time, these taste compounds in Pilsner beer were determined, and in the end, it showed the additive contribution of iso-alpha acids and the identified hard resin components to be truly necessary and sufficient for constructing the authentic beer percept of beer, bitter percept of beer. And this state of knowledge is also now, you can read it in review papers, for example, in a review paper published in 2019, where the authors report on hop compounds in general. And all in all, this is the end of this paragraph. Their message is that all in all, even minor hop compounds may be significant carriers of taste, not only from the soft resin, but also from the hard resin fraction of hops. Nevertheless, it was a fantastic work of Dresel, but he could not cover all questions in this paper. There are some open questions. He could find them in some hop varieties, but are these hop resin components present in all hop varieties? What are the fluctuations from year to year? And what is their fate during hop processing? But Dresel gave an answer also to most of these questions, because one year later, there was another paper in Journal of Agriculture and Food Chemistry. And he analyzed 75 hop samples and on 117 key bitter tastants by HPLC MS-MS. So not only the hard resin key bitter tastants, but also iso-alpha acids, and residual alpha acids, beta acids, and degradation products or conformation products during wort boiling were analyzed. And for us, the important message is that the various hard resin components were detectable in all varieties and in almost all hop products. Most of the identified native hard resin components were only present in trace amounts. This is also given in this paper of Dresel in 2016. Just 4 components are showing concentrations clearly above 0.01%, xanthohomol, co-multivital glucoside, quercetin glucoside, and camphorol glucoside. Therefore, these are the 4 lead components of the native hard resins. Dresel also analyzed different hop products, and he could show that in pellets, all these components, xanthohomol and the other prenylflavonoids, multivital glucosides, and the glycosides of camphorol and quercetin are present, are fully transferred from hops to pellets. With regard to ethanol extract, xanthohomol and other prenylflavonoids are fully recovered. Multivital glucosides and glycosides of camphorol and quercetin are recovered to a certain extent. But these components are not present in regular carbon dioxide extract. So the hard resin components are present in ethanol extract, and therefore this hop product, this extract type, can also be named as total resin extract with all the soft and hard resin components. Then we come to the question, what is the range of these components in different crop years? And these are studies now that we have done in-house. Xanthohomol, I told you, is already known since 1999. So immediately after we heard about xanthohomol, we started the analysis of more than 50 international varieties from crops 1998 to 2001. We did the analysis by HPLC UV, and the result was that the xanthohomol content has a wide range. In minimum concentration is 0.2% and the maximal concentration is 0.1% in the variety Hallertau Taurus. We have published these results in Hopfenrundschau International 2002, 2003. So this is me 20 years ago, a younger guy than today. And this HPLC method that we used in this study is nowadays also an EBC method published, or it appeared in 2018. So what is the range of other hard resin polyphenols in different crop years? And this is now a very recent study. We did in-house analysis of more than 40 international varieties, crops 18, 19, and crop 2020 is also included already. We do this study by HPLC MS, and we have published the according method a few years ago in the Brewing Science journal. We developed it at first for the analysis of hop flavonoids in dry hop beers, and for this purpose we do a direct injection of beer samples after dilution with the HPLC solvent. But in the meantime, we have also adopted the method for analysis of hop samples, and we do an extraction of the hop sample with the HPLC solvent, and then we do the injection to HPLC. And here you see the results, or one slide, and it's a little bit complicated, but I will lead you through it. This is as an example, the co-multivital glucoside concentration in hops and pellets of 2 different varieties in 2 different crop years. I have presented this data just recently at the virtual WBC World Brewing Congress as an oral paper. We investigated, or here are given two varieties, the bitter variety Hercules. So in crop 2019, the mean value for this variety for the raw hops was 0.12, and all in all we analyzed 70 raw hop samples of this variety, and you see it's a wide range, 0.08 to 0.17, resulting in the mean value of 0.12. We also analyzed pellets type 90 of the same variety, 27 samples, resulting in almost the same mean value and almost the same minimum maximum range. For this bitter variety, usually we have no pellet type 45, and because the pellet and raw hop values are very similar, we took them all together. So we had from 97 total samples a mean value of 0.12, whereas we did the same in crop 2018, and the mean value was significantly lower, 0.07. So this shows that you have differences between crop years, but you have also a wide difference of these concentrations within one variety. And the same with the Pellet. Here we also have concentrations for pellet type 45, because this aroma variety is also processed to pellet type 45. But again, the mean values for raw hops, pellet type 90 and pellet type 45 are very similar. So the total mean for crop 19 was 0.13, and in the 18 crop we had 0.10. This shows us that to get a reliable assessment for these components which are present in rather low concentration, you really need a large number of samples from different fields and years to give a specification per variety. And we are still busy in doing this analysis, and the studies for crop 2020 are still going on. Just as an example, I just showed you the co-multivital glucosides, and here in comparison the multivital glucosides. Here the concentration is not given in percent but in milligram per 100 gram, but 120 milligram per 100 gram is the same concentration for Hercules than 0.12% given just before. So these are the results from the 97 Hercules samples, and the co-multivital is higher than the multivital. And this is true for all the varieties. It's very interesting that the aroma variety Hersbrucker is very, very low in both and co-multivital glucoside. Czech and Slovenian hops are also given here as an example. Overall, we analyzed 42 varieties, and the average for the co-multivital was 0.08% for all the varieties and 0.03% for multivital. The same for the camphorol and quercetin glucosides. Again, the same 6 varieties, and the camphorol glucoside is always lower as compared to the quercetin glucoside. The aroma hops here in Hersbrucker, Sarzer, Silea are more or less higher than the bitter varieties, and so this is not the case for the multivitals, but this is the case more for the quercetin and quercetin glucosides. The total average camphorol glucoside value is 0.02, and for the quercetin glucoside, the total average is 0.05%. So this slide shows you that there is a wide range of these components within varieties and within crop years. So these open questions from the first paper of Dresel are now answered. Dresel himself answered them with regard to they are detectable in every hop variety, but show large fluctuations. We could give the answer, and you could see that there are some fluctuations from year to year, and Dresel already reported in the paper of 2016 that they are all transferred to pellets, but not to all types of extracts. But this is now state of knowledge, but these trials were done in lab scale. So it's very important fundamental research. But what is given in brewing practice? And the main concern is, okay, positive, is it really not negative? And this is something we investigated also a few years ago. So now I come to the brewing trials. And we did some investigations in cooperation with the Technical University Munich Weihenstephan Chair of Brewing and Beverage Technology. And the 2 authors, or we published these results in Hopfenrundschau International 2016-17. And the 2 authors is me again, so now 20 years older, and another young guy, it's now Sandro Cucuzza. And here is the trial design of the study. 3 beers were produced with different hop products. There was only one single hop addition at start of boil. The goal was a lager beer. Brewing trials were done at the 6 hectoliter scale pilot brewery in Weinstefan. Each hop product was tested in duplicate, and we did the special analysis using the LC-MS method that I mentioned before, and the sensory tests were done at panels at the Technical University and our own panel. And for these studies, we produced a special hop product, which was enriched in hard resins. We started with ethanol extract, having all the total resins. We did a secondary extraction with supercritical CO2. And the extraction residue then are the total hard resins of hops, because ethanol extract has low amounts of iso-alpha acids. These residual iso-alpha acids are also present in this hard resin extract. And the resulting CO2 extract contains the total soft resins, alpha and beta acids. Now we know also holopones and humulinones can be contained there, and the essential oil. But we did the trial with the total hard resin extract. So 3 types of hop products were used for the studies, all from the variety Taurus crop 2013. And here are the compositions of the compounds. So one compound was a regular pellet type 90. Then the total resin extract, the ethanol extract, was used in the trial, and this hard resin extract that I explained just before. The iso-alpha acids concentrations of pellets is 0. In total resin extract, you have low amounts of iso-alpha acids, and they are enriched in the total resin extract. You have also some residual alpha acids in the hard resin extract. You see the cohumulone does not show any shift. Beta acids are very low in the hard resin extract. Xanthohumol is enriched in the hard resin extract considerably, and the total resin content is given here, whereas the bitter variety Taurus shows about 30% total resins. The total resin extract shows about 90% total resins, and the hard resin extract only shows total resins. And if you now have a look to the relative hard resin ratio, you see that pellet type 90 and total resin extract are very similar, whereas the hard resin extract is very enriched in hard resins. And the total oil content is also not given in the hard resin extract. And these are now the results of the beers. All beer were produced in duplicate, so you see all the single numbers here. Xanthohumol is not included in the beer, only low amounts in the hard resin extract. But there is a higher amount of isoxanthohumol due to the conversion during wort boiling. The co-multivital is given in these beers, the camphorol glucoside and the quercetin glucoside. And you see here that with the hard resin extract, a considerably higher amount of the single components representing the hard resin fraction is transferred to beer. So this is the analytical verification that with this hard resin extract, we really could transfer a lot of lead components representing the hard resins. And so this beer 5 and 6 contained much more hard resins as compared to beers 1, 2, 3, and 4. They were similar in hard resin content. And as a summary from all the tastings, I show you the result of the tasting panel at the Technical University Munich Weinstefan. So the beers were tasted in the fresh stage and after storage for 6 months at 5 degrees, and you see very, very similar values and no big differences between the various products. So the summary of this study is that the total resin extract seems to be an equivalent replacement for pellets, and even strong enrichment of these native hard resins do not result in any negative influence of beer quality. And this is, I think, the most important message. Hard resins are positive from a scientific point of view, and let's say from a fundamental research view, and they have definitely no, or they seem to have no negative influence on beer quality in practice. Last but not least, I will also give you some information on results from dry hopping. We produced various beers in our Hopsteiner 5 hectoliter pilot brewery and analyzed them by our LC-MS method, published in Brewing Science in 2017. I have mentioned it before. There was a basic pale ale only hopped with Pellets type 90, variety Hallertau tradition, and this hopping was during wort boiling. And then this basic pale ale was dry hopped with 2 different varieties at a rate of 500 grams per hectoliter from the lemon drop or Bravo variety. And here you see the results of the beer. You have already all these components: co-multivital glucoside, quercetin glucoside, camphor glucoside, and isoxanthohomol resulting from xanthomol in the basic beer. But the co-multivital, the quercetin, and the camphor glucosides get higher after dry hopping. These components are very polar, so they are transferred to beer via dry hopping. And xanthomol goes down, probably because of some precipitation, haze building. And xanthomol, on the other hand, can be introduced to the base beer via dry hopping. So this is the picture coming from the dry hopping. And my last slide is another aspect, but I think it's worth to mention. In 2014, a group in the USA published a paper, and the title is "American India Pale Ale Matrix: Rich Xanthomol is Potent in Suppressing Proliferation and Elevating Apoptosis of Human colon cancer cells." So there is some cancer activity, and they also found out that high levels of xanthomol are due to the usage of large amounts of hops for dry hopping in IPAs. So IPAs are high in xanthomol, and this high content could further increase to almost 13 milligram per liter by addition of dark malts. And this positive effect, as described in the title, comes from this beer with the high addition of dark malt, showing 13 milligram per liter of xanthomol. So it's a good message, and don't forget that these components from hard resins can also improve the positive image of beer by publications like this. So I am ready with my talk. To sum up, I could show you that during the oxidative storage, hard resin components are built from alpha and beta acids. Until today, their contribution to beer quality is not fully clarified. On the contrary, we know much more about the native hard resins. These native hard resins of fresh cones and hop products are consisting of a large number of various single components. They all belong to the class of polyphenols, but most of them are only present in traces. For all varieties, the prenylflavonic xanthomol is the main component. Another class of polyphenols is mainly represented by the glucosides of co-multivital, quercetin, and camphorol. So these can be considered as the 4 lead components of native hard resins. Altogether, these hard resin polyphenols make a positive contribution to the bitter profile of beer. This was proven in lab scale, and in brewing practice, no negative influence on beer quality could be observed. The polar hard resin polyphenols are transferred to beer both via conventional and dry hopping. And then, because hop purchase and dosage is usually based on alpha acids, for brewers, hard resins are complementary but nice to have, also with regard to the health promoting potential. So I would like to thank you for your attention, and I would like to thank the Hopsteiner lab and brewing team. This is the end of my presentation, and Sandro, I think you have some questions for me.
Yes, right. Yeah, first of all, I have a comment for you. Thank you very much for sharing your picture that showed you 20 years ago.
Yeah.
So this is was very nice for everybody to know how long you are already working on those topics, especially with regard to xanthomol. And like this, everybody has also a picture besides a lot of publications on the screen now. So that's wonderful. Okay.
But also a picture with you.
True, that's true. Yes, the newer one. Okay. Yeah, it's really interesting that you have shown so many single components that that were in the focus, and we have seen that there's so much contribution to a lot of issues. On the other hand, a couple of them are far below the thresholds, but maybe in summary, as you shown in the beginning, the whole complex story of the hard resins is clearly showed us that there's clearly an impact on taste, intensity, and quality, I guess. When it comes to the single components, there's one question that came up. Are there any possibilities for the analytical side how to determine the single components, and what are your recommendations for doing this?
Okay, as I've shown in my presentation, we have focused on the main components present in high concentrations. We know that these lead components are representative for the whole fraction. So xanthomol of hops or isoxanthomol in beer, and the multivital quercetin and glucosides. They can be analyzed. For the glucosidic or glycosidic bond components, an HPLC-MS method is necessary. Xanthomol, isoxanthomol can also be done by HPLC-UV, but they can also be included in an HPLC-MS method. But HPLC-MS, I think, is necessary to do this analysis.
Okay.
So
and with such equipment, I guess you can also distinguish
expensive equipment. Not everybody has it in his lab, of course. Yeah.
Sure. Yeah. And with such equipment, I guess you can also distinguish between the fractions of the native hard resins and the aged hard resins, correct?
Of course, yeah. Regarding the stored, the aged hard resins, we don't have the standards available. So at the moment, we do not analyze them. But in the studies of Dresel, these compounds, he could not find them in the native hard resins. So this is it's very clear that they only show up during oxidative storage, and such an oxidative storage, of course, is not very usual, and therefore, usually the hop products, they don't contain them.
Okay. As you just mentioned in the end, that you can increase the concentration of such components, especially the leading components that you have shown in case of dry hopping. Do you think they play a significant role in the overall taste, or what do you think?
Yeah, definitely. So for co-multivital, the bitter taste threshold is 1.8 milligram per liter, and in all these, or the two dry hop beers that I showed before, you had concentrations above this threshold. So even this single component has a direct contribution to beer bitterness. And the bitterness of dry hop beers is definitely influenced by hard resins. It's much more influenced than regular beer is influenced by hard resins. Most of them are polar, and they go to the beer directly after dry hopping. But again, there are not many studies going on or that have been done in this direction, and we were one of the first to detect them in this dry hop beers because we have this method established.
Perfect. Maybe we can use it and use our hard resin extract from the previous studies and to make some dry hopping trials now. Then we clearly see the impact on the taste. So maybe we come up with this pretty soon.
Good idea. Yeah, we have done several trials with such an extract many years before, because we wanted to see how xanthomol can be enriched in such beers. And so the focus was not the taste of the beers, but the xanthomol enrichment. but we always got the impression that this hard resin beers are very well accepted. So we already had this in mind since many years, and then the fantastic work of Dresel, it more or less confirmed our practical findings, and now we know it definitely that hard resins have more a positive contribution.
Okay, perfect. Another question's coming in. Do you see, is there any hop variety that stands out with particularly high hard resin concentrations? Have you observed something in your studies, or maybe you mentioned also that the studies for 2020 are still going on? Maybe there's some, you found some of the new breeding lines that is pretty high.
Yeah, no, we did not cover new breeding lines. We even did not cover many US varieties in this studies on co-multivital quercetin and so on. So this is some varieties are still missing. But we, of course, we do on a regular basis, we do the total resins of all the hop varieties. And in the end, we do not see much difference. So it's not a factor of 2 or so with regard to the total fraction. Maybe some single components can be higher in one variety as compared to another. For example, Hersbrucker, very low in co-multividol as compared to all other varieties, but higher in quercetin and camphorol. So it's a little bit compensating, obviously, and so the total resin content of the varieties is rather similar and rather stable. And because they make interaction with the same receptors, in the end, the resulting bitterness is very comparable, I would say.
Okay, maybe when it comes to the aged or the stored resin fraction, then we see major differences between the varieties. Probably here, as we know, that some varieties are more stable than others regarding storage. Maybe the differences could be bigger over the time. What do you think about that?
Yeah, this is something you can expect. You have more stable varieties, and of course the building of this deterioration products, this isohomolons and so on, this will go on faster in this. This is something that I would expect. Yeah.
Yeah. Okay, as to the same question, an additional question came up. So, but I guess you mentioned it already. We did not include the varieties over the world, so you cannot say something about trends that are regional or also. I guess this is
only with xanthomol we have a good picture, and with the co-multividols we have focused on European varieties for the first, or in the crop years 18 and 90, and we only include the US varieties in the crop 20.
Okay, as you just mentioned, xanthomol, what is the current status about this interesting component? I guess there's plenty of research going on, and finally also some clinical trials on the human body. So maybe you would like to comment that.
How much time do I have? No, to make it very short.
2 more minutes.
Since 1999, almost or more than 500 or around 500 papers on xanthomol and health were published, and these publications are going on, and the research goes on worldwide in the US, in Japan, in Europe, China, Korea, and we are now in the stage of human trials. First results of human trials are coming up. Xanthomol anti-diabetic activity, and so it takes very long to get to this stage, but now we are there, and it's definitely still a very promising compound. And
okay, so we are curious
one aspect, because I mentioned antiviral activity, so maybe this could also be a good potential of xanthomol if we can show that it can help to improve the immune system or have a direct antiviral effect. But yeah, the research in this area just started.
Yeah. Perfect. Okay. There was another question that came in earlier, but I put it out from the first topics because it's not directly connected to the hard resins. But what do you think? Where does this reason comes from that a lot of brewers assess the cohumulone to be not so good for the taste?
Yeah, because in the, I would say, 80s, there were results from brewing trials showing that varieties high in cohumulone content resulted in a less preferred bitterness as compared to varieties with low cohumulone content. But these were different varieties, and maybe the conclusion that the only reason is the high or low cohumulone content was not the right one. Later on, some isolated compounds were added to beer, and the studies didn't find a big difference. So I would say this is not really solved, this question whether cohumulone has a positive or negative impact. My personal opinion or my conclusion from all the literature is that there is not a big difference between cohumulone and adhumulone bitterness. And another reason is that cohumulone is a little bit better soluble in beer, so you always have some enrichment of cohumulone. And if you, yeah.
So regarding yield, it's even an advantage, but considering that Hercules is the major bitter variety in the Hallertau, which has a rather high cohumulone, I guess that everybody uses this variety, and if in case it would be harsh or not so good in bitter quality, I guess nobody would use the Hercules. So for me, this is the proof that this old literature is copied many times, but as you say, there's no real proof for the cohumulone to be.
And even with the even with the pure compounds, this could not be confirmed in the end. And Hercules has another advantage. It's very high in alpha, so you don't have to dose very much of it. We had in former years, we had a variety, Brewer's Gold. It only showed about 8% of alpha acids, but a very high cohumulone content, more than 40%. And this maybe was a very extreme variety with regard to cohumulone introduction to beer. But Hercules is not really out of the range. It's on the higher end, but it's still within a certain limit, I would say.
Yeah, absolutely. Okay, perfect. Well, then we covered all the questions. Thank you very much again for this very interesting presentation, and I guess we clarified all the questions. There were also some questions about the papers to be handed out and so on. Of course, we do this later by email. And otherwise, you have also the possibility to rewatch this presentation again, and there you also find all the slides that Martin just showed, and including all the references. Okay, Martin, it's time to close the session. Any final word from you?
Stay healthy, all of you, and I hope to meet you soon in direct contact.
Perfect. That's a good point. We will stay healthy, and in this case, we will see each other again on the 4th of March at the same time. Then our technical director, Frank Pfeiffer, will talk about hop products for low and non-alcoholic beers. I'm quite sure this will be a very interesting topic. It was requested many times in the recent months, and especially with regard to the current beer trends, I'm sure we will cover a lot of helpful information for the production of those kind of beers. Thank you once again, and stay healthy, and talk to you soon again. Bye-bye.